Hello everyone and welcome to another video on Dynamo for Alias. Today we're going to dive into a little more of a practical example. We're going to try and recreate what I've made here in Dynamo, which is basically taking a normal surface, which if I can display it right here, let me just pick plane. Here we go. So we take this simple NURB surface, and by sending it to Dynamo, we get the output surface, which is here. Uh, let me delete those locators. Here we go, and turn off the model. So you see like tessellated surfaces, triangles all around this surface. Okay, so first of all, I'm gonna start by creating a new file. And just putting in, who cares? Let's draw a couple of curves. Oh, just do a plane, more simple. Plane, scale that up. Show me the CVs. This guy up. Let's do something a little bit fancy. On prop mode. Up, up. Turn that up. Make it, big CV. Move. Anyway, you know this part. That's the easy one. All right. Move that up a little bit. All right. Now we start the Dynamo tool. And we just wait for it to pop up. No, it's already active. So double click. There we go. Connected. We open a new file, and there we go. So let's start by, first of all, sending the surface. So select from Alias, click, send, show me Dynamo again, and click on this guy to fit the viewport around my object. Now, the way to achieve the tessellation is by, first of all, I'm just going to do it visually. So we need to draw lines along the U or V surface along a direction. So in surfacing, we call those isolines. So there's a note for that. It's called get isolines. Isolines, get isoline, here we go. And I just feed my surface, my NURB surface into the surface port. At the moment, we're only going to be focusing on single surfaces. So please bear that in mind. I will do a video later on multiple surfaces and how we can achieve the same result, but it's a word to the wise is that it's more complicated. So for now, for this first Dynamo applied video, we're only going to be focusing on single surfaces. Right, so we get the ISO direction, which is either 1 or 0. So let's do a quick slider and put a 0 as minimum, 1 as maximum, and a step 1. So as you can see, it switches only between 1 and 0 really quickly. And ISO direction. And let me just save my file. Dynamo. Okay. Now, parameter. And for now, I was just going to show you put 0.5 as my parameter. Maybe you can hear a background noise. The churches here are ringing pretty loudly. Anyway, so now you can see the parameter is 0.5, which is exactly the center, the middle of that direction. And if I flip between the two directions, you get the idea. Anyway, we don't want just one line. We want a certain amount of lines flowing in that direction. So let's imagine that we have, first of all, another slider and put it on an integer and call that number of lines. And it'll be from, we want at least 2 of them, so minimum will be 2. And let's keep the maximum, I don't know, something reasonable for now. Let's keep it at 30, right? Save. And we want to put that into the parameter space in some way or another. So to do that, we have to create a list. So to create a list, you always use code blocks. So the parameter space starts from 0 and ends at 1. So 0, double dot 1, double dot amount of lines with a hashtag. So amount of lines, or shall we say, let's stick to the same title here, so number. And if I click here and connect those two, it'll give me a list. At the moment it's only 2, but if I push this guy up and 3, 4, so if I have 6, yeah, that's correct. So 7 lines will give me 7 values from 0 to 1 divided with the exact step in between. And I connect this to the parameter, and as you can see, we get 1, 2, 3, 4, 5, 6, 7. We can always change if we need to modify that later on, but for now it works. So let's just move on. Now we need to sample each, let me turn that off so it's a little bit clearer. Sample each curve and put points on each one. So because to draw our triangles, we'll need 3 points. Anyway, so we use another node called get point at parameter. Point at parameter, and make sure you choose the one which takes a curve as an input, because the other one, the third one here, takes a surface, and we don't want that. So let's take points. Now, and it works the same way as the isoline, as in take the curve, put that in, and it's already put the default value 0, so you can see it's got 1 point for each one. Anyhow, we want to do the same logic as here, but we want to use 2 different new nodes. Cool. Let's duplicate those. Number of, let's call it triangles per line. So triangle per line. And by the way, you don't have to do what I'm doing, as in like I use camel case because I'm just used to, that's a habit from programming. But you can just type in whatever you want. It's still a perfectly valid variable. Anyway, keep that in, save, connect those two. Number of triangles. So yeah, every time you change the name of a variable, you have to reconnect. It's a little bit, yeah, something to get used to. Watch out for. Anyway, parameter, same. Connect those two. And you can see, first of all, we have a slight problem. It's only giving us 1 point per curve. And the reason is it's assigning each of these values to each of the curves. So at the moment, both of them are exactly the same number, which is why it kind of works. But if I pump this up to like a higher value, it's taking the first 7 values and assigning them, and then just discarding the rest. And same as if I go lower than 7, it's gonna again ignore a few points, the last few curves. But the way we get around that problem is, let's say we stick to 10, and we want 10 points on each line. We go right click, lacing, cross product, boom, and now we have our 10 points per line. Okay, let's save. And so let me start up Illustrator real quick so you guys can, actually Paint would have done the job. Anyway, let's just keep going with Illustrator. So I'll draw you a simple schematic of what needs to be done. File, new. Right. Okay, so let's draw a first curve. Just bear with me for a second. Okay, so pen tool B. We have a first curve, and we have our, let's say, second one right here. And to draw a triangle, let me no, open the polygon tool, click once, 3. Okay. To draw a range of triangles, we would have to do, let me use a different color for this one, red. Right. We would have to resample the bottom 2 points, and let me also draw a few points. Okay, so this guy goes here. I'm just going to draw the first couple of things so you guys really, it's I mean, so for some of you it might be really easy to understand, but I like to spell things out quite literally, so there's no excuse, and then you can really see what I'm attempting to do. Because once I get into the whole list manipulation, it's quite easy to get lost or confused. Anyway, right, zoom in. Right. Uh, uh, right. Okay. So to draw the first series of triangles, we have to sample the first bottom 2 points and the top 1 point, and we'll form a triangle like this. And for the second triangle, let's go like this. And anyway, you get the idea. One. Here we go. But that will only create one half of the triangles that needs to be created. So, and then we'll have to do a second set of triangles, and I'll color these in a different color. Let's put them in green. Here we go. Who cares? And those will be one here and here. And then we'll get one set of triangles, two set of triangles for each of the curves. And we will get our fully, I'll call it tessellated. I'm not sure if that's the right terminology, but all the triangles will be exactly at the right position. So yeah, I hope that was clear enough. Anyway, let's get back to Dynamo, and let's achieve what this is doing. So first we have to create the bottom 2 points for each triangle. So we're going to take this list and create subsets of sublists, by resampling the first 2 points and putting it into a separate list, and then putting 1 and 2 in a separate list, and 2 and 3 into a separate list, and so on and so forth. So there's a node called sublist right here, and yeah, it takes. I'm gonna put in the preview so you guys can see what's exactly happening. Let's put the list. The ranges, it takes of index ranges. So for each of our sublist, we only want the first 2 items. So there's a couple of ways you can do that. You can do 0 to 1, which gives us the first 2 indices of each one, which is 0 and 1. Or the other way to create exactly the same list would be to be explicit, as in 0, 1, and that's exactly the same thing. Exactly. So we put that as a range, and that will give us the first two indices of the sublist, and we're still missing the offset factor, and the offset will be 1 because we take the first two and then we push our or offset rather by one value and take the following two and then the following two, each offsetted by 1. So we click 1 and we put that into offset, and the problem is it's doing that over the whole list of lists, and we need it to operate on a list at level. So we click on this icon, check use levels, and well, it did it automatically. So let's just make sure that we are doing the correct job. By clicking here, I'm highlighting the first row of points, which is great. And let's click on this. We get the first two. Perfect. If we click on the following sublist, you can see it shifted or offsetted by 1, and it still took the first two indices. So what it did is, let me just unhighlight this. It did take this one, put it into a sublist, take the same one and the following one sublist, same following one, and again until we get the whole thing. Right. Now, if we scroll down and let's take this out, preview off, so and save, you can see at the end of each, it's no matter how many points I have. Let's use another, let's say 11, right? So now we have a completely different number. I mean, it's going to be not an uneven, like an odd number of points. We still get 1 point left at the end alone, and we don't want that because this is going to form the bottom 2 points, and that point is unnecessary. So what we do is we use a node called drop, and it says that if the amount of items is negative, it will drop items at the end of the list. So click, use that as my list, and the amount, we only want the last one of this sublist, so we're going to put -1. Put that in there, and let me turn on that so we get an idea of what's going on. And let's see if it removed. No, it didn't remove the thing. And again, it's the same as before. List, use levels, and operate at, if I'm not mistaken, L2. So no, I am mistaken. So let's go back to L1. No, it must be L3. All right, that's a little bit better. We still have the same number of sublevels. And let's scroll down. Okay, and as you can compare, this guy is gone and it's not there anymore. Perfect. So turn this off, preview. Now we have the bottom 2 points of each triangle for the first set of triangles. So I'm gonna, for all intents and purposes, I'm gonna take this, I'm gonna group them, Control G, and I'm gonna call this bottom 2 points of triangle Z. Right, save. And now we're going to reuse our original curves and find the top points for each triangle. And that's a little bit, well, it's kind of the same. So let's do. We want to take this list and basically get 1. So let's copy and paste this. We only want 1 value here, so it's 0. Actually, let's see what that does. Okay. Turn preview on. Turn this guy off. Okay, so Okay, so I see what the problem is first of all, we don't need that first curve, so we need to discard the first curve, the first list. So we do that with, first of all, let's do it on this list. So let me just, I must have something selected. Yeah, right here. Turn the preview on. And I want to discard the first curve or the first sublist. So we drop. And here, instead of using a negative value, we use a positive value. So 0.1 and list at level L2, I believe. Let's see if I'm correct. And no, L1, no, L3. Okay, here we go. So now we've completely discarded the first set of points, which is exactly what we want. And we need to slice, create sublists of only 1 point. So I forgot if it's slice or, let's go for sublist, see what happens. So I'm gonna reuse these, click. We only want the first item, so we don't need to use the brackets, just 0. Turn this off, turn this on. Right. What did that do? Click 1, 2, 3, and okay, that seems to have worked, and we're not gonna need that last point. So let's drop it. Drop. -1 because we want to drop the last amount, the last point, and we're going to need to operate at L2. No, L3. Yeah. Now if I click on this, it's dropped the last point, which is unnecessary for our first set of triangles. Right, okay, so we have the bottom 2 points and the top 1 point. So click, points of triangles. Okay, now we have our 2 points and our 1 points. You can guess we have our 3 points for each triangles, and we need to find a way to add that 1 point to, oops, sorry, let me scroll up to these 2 points here. So it goes 1, 2, 3, and forms a triangle. Right, let's do that. We have to use a node called list add, and you can choose add item at end or at the front. So you can see it's either at the start or at the end of a list. Because we are dealing with a triangle, and well, let's wait, 1, 2, 3. Whether we add it at the beginning or at the end, it doesn't matter. So add item at front. Who cares? All right, let's unhighlight these and add our point is going to be our item, and the 2 points is going to be our list. And obviously there's a problem because we need to use list at level for both items. And usually what happens here is I just play with the levels until I get a sublist of 3 points flat, because here it's not, I could use the flattened list node, but let's just do it the proper way. Let's be clean. There we go, L1, L2, we get points of, triplets of points. So let's turn this off. Close, close, save. And now we need to form triangles out of 3 points. We do that by using the polygon by points. where is it? Okay, let me just polygon by points, and it takes a list of points, which is exactly what we have. Click, and it drew a bunch of triangles, which are not surfaces, and to turn polygons or closed curves in general into surfaces, we use the patch node by patch, feed the polygons into the closed curves, and booyah, there you go. We have our first set of triangles. We basically have the red triangles, and now we need to do the same thing with the other set of the same points, but manipulated in a different way to get the second set. Okay, let's do that. So, zoom out. Right. So let's group this, put it on the side, turn it off. We don't need it for now. We know it's right as long as we don't mess with our nodes. It'll be there. Okay. Now we need to, let's start over again. We need to take the, what was it? Okay, so the one bottom triangle, one bottom 1 point. There we go. So we need to discard, drop the first. Drop items. Okay, so now that you got the idea for the first one, I'll go a little bit faster. I'll still want a live code because it's important for you to understand each step of the way, so you can pause and take notes or whatever. And also, if I make any mistakes, I can guide you through those mistakes because you might make those same mistakes, and I'll be able to give you advice if need be. Right. So we want to drop, what was it, the first one. So 1 at L2. Right, so we did drop the first point for each one. Perfect. And we need to do what we said. We said it was the bottom 1 point. So let's see what we got. Okay, so sublist. The range, I'm gonna reuse 0 and 1. List at level. Cool. Am I doing this right? Yes, 1, 1, 1, 1, 1. And we do need that first point, so no more dropping here needed. Yeah, yeah, I think that's it for now. Yeah, and wait, I know I'm missing something. We don't need this because we don't need that last one. So again, could we do it on this? Yeah, it's a little bit cleaner. So drop -1. Okay. Turn this off for just a second. Okay, so I'm turning this off too. This, okay, I've got everything I need. The bottom to form the bottom triangle, and we turn this off, turn this on, save, and everything should be split into single point sublists. Let me just make sure I've got everything. Yeah, all right, looks good. So this is already done. and we'll clearly label this. It's the bottom 1 point of each triangle. Right, and now we need to get the 2 top points for each triangle. Okay, so we are not going to need the first. How does it work? Let me go back to my drawing. We are not going to need the first curve. So drop 1, which is already what's happening here, I believe. No, okay, let me just avoid confusion and start over. Drop, sorry, drop. And yeah, okay, we don't need the first curve, so let's discard it. Perfect. And we need to do a let's need to think for a second. Let's create a sublist of 2. So that's my list. The ranges is 0 to 1, and my offset is just 1. Yes. Okay. Let me just make sure. Okay. Yeah. And I should have a single point at the end, which we drop. Okay. And you got it by now. If I want to drop the last one, I use -1. It's gonna drop the first, I used to use list at levels to drop the point that is a list within a list. So use a level. And let me just make sure I've got the right L3, and index 10 is gone. Perfect. And yeah, let me highlight it. So 1, 2, 3, 4, 5. Okay, that is good. That is good. Okay, we're almost at the end now, and that is our top, yeah, top 2 points of each triangle. And we do the same as here. So that was set 1, and we need to duplicate and use set 2. Obviously, we disconnect everything here. Click, okay. And as I said, the order doesn't matter, so we can connect them in whichever way. Let's use the same one as before. Okay, something is clearly wrong. Let me just do L2 here and L1 there. No. Okay, this is interesting. Let me try. Should not matter, but okay, this is definitely interesting. I mean, I know I can achieve what I want from here, but I also know I should be able to achieve what I... No, I think I know what I'm doing wrong. No. Yeah, no, that looks consistent. So what was the setting of the L1 and L2? Okay, so well, I'm gonna try. There we go. Don't try to recreate don't try to solve problems that have already been solved. If you already did it here, just copy and paste. Most like 99% of the time it works. Don't try and spend time. Anyway, at least you know by now. All right. So now let's turn on our uh, surfaces here. Preview on, and ta-da! We get our second set of surfaces. Let's save. Let's put this one here. Turn on the preview of our first set. And as you can see, we have exactly what we wanted. Right. And okay, so the cool thing now is that you'll be able to change the number of lines and change the number of, isolines and number of triangles per row. So kind of like grid X and grid Y. And yeah, what I like to do is gather my inputs or whatever controls my script into like a group. So I put it here, and I always put it in orange because force of habit, and controls, and I save this. Obviously, this only at the moment, this script only works for single surfaces. So please bear that in mind. Don't send two surfaces or two discontinuous surfaces. It will not work. At the moment, it only works for single surfaces. But the cool thing is, let me shove the UI around a little bit. Oh, let me go like this and make this bigger. And you can see, if I increase the number of lines, it recalculates everything automatically. And same as here, if I go low, I get exactly what I want. So I lose once you bake that back. If you have continuous surfaces that were G0 or G1 continuous or G2 continuous, whatever, um, to the original surface, because it's tessellated, you will lose continuity, but you know that already. Anyway, let me. I find that aesthetically, I get the best looking results when I get a mix of high and low values, but I try to keep really low because it's mostly the effect desired. Anyway, that's that. 6 by 7 by 6. There we go. We get a healthy amount of surfaces. And now let's bake this back to Alias. So if I use the bake node straight up like this, I'm going to show you. Up. That's it. It's already done. It's baked 30 surfaces. The problem is uh, now let me do a pick object and pick my original plane. Yes. And make that invisible. Shade on. I've only baked half of only one set out of two. And to bake the two together, let me restore history, query it, click. There we go. To bake this one, these two groups of surfaces, list of surfaces, should I say, into Alias, I can either use two bake nodes, which is a little bit not very efficient, not very clean. What you can do is create a list by list create, input two items, and these 60 surfaces, you can just, let me just turn the preview off because it's already here. You bake the output of that list into Alias. So click, takes a fraction of a second, save. This takes not a lot of time because it's a fairly simple script. Anyway, if we were to push the script to its limits, it would be a different story. But yeah, that's just a word to the wise here. Anyway, we baked the geometry. Let's go back to ADS. and it's there, but it's just not shaded at the moment. So let me just turn on shading like this, and voila. And the very cool thing about this now is if I do a pick object, and I want my original surface back. And for now, let's turn off the tessellated Dynamo surfaces. Right. And if I choose to move a few CVs, or you know what? Let's take these two CVs, these row of CVs, and move them with my grid. So in the X direction, like this. Here we go. Pick nothing, and shade everything. Turn all the objects visible, and voila. If I do a pick object and make that invisible, you can see that my surface has been tessellated, and I can always query edit, click, and change the parameters to something more pleasing. So let's increase the number of lines, maybe triangles. Yeah, let's pump that up a little bit. And yeah, so you may notice here that the isolines are not equally spaced. And that's because, as you may know already, isolines are based on the UV parameters, like parameters from 0 to 1, and that depends on the layout of your original surface. So because I changed my surface layout to something with uh, a suboptimal CV layout, let me just, as you can see here, it's definitely not a great CV layout, but for the sake of the example, we're just going to accept that. So that's why the layout, I need to query edit. That's why the layout is not that great. But I can fix that just by going into Alias and doing a pick CV, selecting those CV, move them, oops. So yeah, put that here, pick nothing, pick CV. Anyway, you know, this is the easy part, you know this. And yeah, so now it's a lot more even. And you can see that the triangles are a lot more even now. Anyway, yeah, so that was it. I hope you like the video. And I'll be sharing the file and putting the link into the description so you can open this Dynamo script and wire file. Maybe not the wire file, but I'll be sharing definitely the Dynamo script so you guys can open and study it. Okay, let me know in the comments if you liked the video. Please share, like, and subscribe, and I'll see you next time for another video on Dynamo for Alias.